Hi everyone, I'm Kia. I came here with another topic of vector algebra known as scalar triple product. I will explain each and every concept of scalar product, right? Triple product. In fact, what kind of operations can be applied between two vectors? Between two vectors, we can apply addition, subtraction, dot product, and cross product, right? Writing two vectors side by side is not a valid expression, or applying dot or cross between scalar and vector are not at all valid expressions. Here are a few things which I wrote that A dot B into C is a valid expression because this is scalar into vector, right? A dot B cross C is not valid expression, is not valid expression. Remember, this is not valid expression because here this is a scalar quantity and this is a vector quantity, isn't it? This is scalar quantity and this is a vector quantity in that way. And A cross B into C bar is not a valid expression because this is a vector and C bar is a vector. Writing two vectors side by side is not at all a good expression. And A cross B dot C is a valid expression because dot is applied between two vectors. A cross B cross C is a valid expression because cross is applied between two vectors. A cross B is a vector. A dot B dot C is not a valid expression. It's not a valid expression. And this is known as this A cross B dot C is called scalar triple product. This is known as scalar triple product. Scalar triple product. There are three vectors where we do apply that cross and dot product at a time. And this output is vector. So this is known as vector triple product. Vector triple product. Now, particularly in this video, I will explain fully what is scalar triple product and what are the simple properties of scalar triple product and geometrical interpretation of scalar triple product. So here the scalar triple product is nothing but that A cross B dot C, A cross B dot C, A cross B dot C is usually denoted by, remember, box ABC, box ABC. Read as box of A bar, B bar, C bar. In this box, we do not allow any commas. We just write the vectors by maintaining a proper space between the vectors. So it is called triple product of vectors. So from now onwards, A cross B dot C is denoted by box ABC. So we have a new notation that box ABC is nothing but cross product of two consecutive vectors dot third vector. Right. Here you see that we have applied that B cross C and after that taking dot. This is B cross C and after that taking with dot. Right. Okay. So in that way, we can write, for example, what is box of P bar, Q bar, R bar. You can write that this is P bar dot Q cross R. You can take the cross product between two vectors, two consecutive vectors, that is Q bar and R bar. Or you can write first two vectors cross product, and this is dot R bar. Similarly, what is ijk, box of ijk? Box of ijk equal to, you can write I cross j dot k. I cross j is nothing but k and k dot k is nothing but 1. In this way, you can apply value. Now, I will explain that how do we find out that box of ABC or A cross B dot C directly. Well, here A bar is a vector A1I plus B1J plus C1K, and B bar is a vector A2I plus B2J plus C2K. Okay. And C bar is a vector A3I plus B3J plus C3K. First, we need to find out that A bar cross B bar. Okay. Well, so what is A bar cross B bar vector? As you know that cross product of two vectors can be obtained from the determinant, that is determinant of I, J, K, and A bar vector is A1, B1, C1. It is so simple, and third row is A2, B2, C2. This is the process of obtaining A bar cross B bar. So on expanding this, we got this expression. And after that, you apply dot with C bar. This is A bar cross B bar. This you apply dot with the C bar vector. Dot with the C bar vector. Right? Then you will have that A3 into B2C2 minus, right? B1C2 minus B2C1. B minus B3 into A1C2 minus A2C1. Plus C3 into A1B2 minus A2B1. Now, if you observe carefully that in place of I, we got A3, in place of J, we got B3, in place of K, we got C3, right? So, in place of I, J, K, in the top row of determinant, you just write A3, B3. So, this entire expression can be written as a determinant of A3, B3 and A3, B3, C3, A1, B1, C1. Now interchange first row and third row. After that again interchange second row and third row. You will get this final determinant. So from now onwards, box of ABC is nothing but determinant of first vector, right? Scalar components. Second row, second vector, scalar components. Third row, third vector, scalar components. So it is so simple now and so sweet also. So it is easy to find out the box ABC is equal to determinant of A1, B1, C1, A2, B2, C2. This is the first vector. And this is the second vector, A bar, B bar. And this is the third vector. Now it is so simple. Now, what are the simple properties of this box ABC? Remember, box ABC is nothing but A cross B dot C. You have to apply cross for two vectors and after that dot with third vector. When will be box is equal to 0? When will be box is equal to 0? Right? That box equal to 0 or nothing, or you can say that, or A cross B dot C equal to 0. A cross B dot C equal to 0. At least one of A bar, B bar, C bar is a null vector. At least one of A bar, B bar, C bar is a null vector. Then box equal to 0. Then box equal to 0. So like that, box of 0 bar, B bar, and C bar equal to 0. Remember, it is a scalar quantity. Or at least two of them are collinear. At least two of them are collinear. At least two of them are collinear, nothing but if A bar and B bar are collinear, then one vector can be written as linear combination of the other vector, A bar, lambda A bar, and C bar. This you can write that A bar cross lambda A bar, isn't it? All right. Into dot C bar. Now A bar cross A bar is 0 bar vector. So we can write this is 0 bar dot C bar equal to 0. And one more important point is A bar, B bar, C bar are coplanar vectors. They are coplanar vectors. So what is the condition for A bar, B bar, C bar are coplanar? That box of A bar, B bar, C bar is equal to 0. Why this condition happens? For coplanar vectors, y box is equal to 0. Y box is equal to 0. Well, you see that A bar cross B bar dot C bar equal to 0. This is nothing but A cross B is perpendicular to C bar. Is perpendicular to C bar. But A cross B is perpendicular to both A bar and B bar. A cross B is perpendicular to A bar comma B bar. All right. So therefore, this implies C bar must be lie in the plane of A bar and B bar. C bar lies in the plane of A bar B bar. All right. If you want, I'll draw a small diagram like this. Okay. And one vector, I'll take that A cross B. All right. This is A bar cross B bar vector. A bar cross B bar vector. And assume this is A bar vector and this is B bar vector. So somewhere you must have that. See, A cross B is perpendicular to C bar vector. It must be in the plane of A bar and B bar. This is C bar vector. So, and if box ABC is not equal to 0, then they are non-coplanar vectors. So what is the condition for non-coplanar vectors? Box ABC is not equal to 0. Well, if C bar is a unit vector, then what is the maximum of box ABC? If C bar is a unit vector, then maximum of box ABC is the cross product of remaining vectors. The cross product of remaining vectors. Well, suppose if A bar is a unit vector, A bar is a unit vector, then what is the maximum of box ABC? Is a unit vector. Then maximum of box ABC is cross product of remaining vectors, modulus of cross product of remaining vectors. It is just simple application of dot product. Box ABC is equal to A bar cross B bar dot C bar. Dot product of two vectors is always less than or equal to product of magnitude of those vectors. Product of magnitudes of those vectors as cos theta less than or equal to 1. Here is one simple example that V bar vector is given, W bar vector is given, and U bar vector is a unit vector. Then asking what is the maximum of box of UVW? What is the maximum of UVW? Okay, right. So that here box of UVW, we want that maximum. So this is less than or equal to magnitude of cross product of remaining vectors, given vectors, V bar cross W bar. So we have to find out what is V bar cross W bar. Well, we can find out V bar cross W bar very easy. It's a matter of only determinant. All right. So here V bar cross W bar is equal to determinant of very simple I, J, K. And what is V bar vector? 2, 1, -1. These are the scalar components. And W bar vector 1, be careful, 3. Oh no, there is no J component. It is 0 and it is 3. All right. Generally, to finish vector algebra, we take around some 15-20 days. So here I am going to explain in just 4 hours. I into This is I into 3 minus j into 6 plus 1, 7 and plus k into minus 1. That's it. Over. So what is the magnitude of V bar cross W bar? Its magnitude equal to root over 9 plus 49 plus 1. That's equal to, this is root over 59. Where is option A? Okay. This is root over 59. Option A is missing. Nice. Okay. So here I'm going to write option A, that is root over 59. All right. Moving to next concept, that what is the geometrical interpretation of box ABC? This is very, very important, right? So we use that box for volume of parallelepiped, for volume of parallelepiped. So if A bar, B bar, C bar be the coterminous edges of a parallelepiped, they are the three consecutive edges of a parallelepiped, right? Suppose A bar, B bar, C bar form a RHS, right-handed system, right? Rotating A bar to B bar in anti-clockwise direction when viewing from top of the C should not exceed 180 degrees. Then the volume of parallelepiped is given by simply box ABC. So from now onwards, box ABC is nothing but that is the volume of parallelepiped. If we know A bar, B bar, C bar form a RHS. I'll give you the proof. I'll give you the proof just in two lines. Just in two lines. So what is the formula of rectangular box? L into B into H. What is meant by L into B? That is the area of base rectangle. And what is H? That is the height of the rectangular box. The same concept we can apply here, that volume of parallelepiped equal to area of base into height. Area of base into height. That's equal. So here area of base into height is nothing but, you observe the diagram, area of OA, right? OBAC. That is the parallelogram. OB, okay, OBAC into height, All right. This is height. So here you observe that this is the parallelogram. Base is the parallelogram. This is the parallelogram. Well, then what is the area of this parallelogram whose adjacent sides are given? Whose adjacent sides are given? Modulus of what are the adjacent sides? That is B bar cross B, C bar. So modulus of B bar cross C bar into H. This is the area of parallelogram whose adjacent sides lie along B bar and C bar. This is the B bar vector and this is the C bar vector. Now we want to find out this height. We want to find out this height. OA, BC, assume this is the, all right, this is P and this point is Q. Vastunna. Yes. Draw. Now this is the B bar cross C bar vector that is perpendicular to B bar and C bar. Drop the perpendicular from P to this line. 1 minute. So here the base is a parallelogram. So area of parallelogram is here B bar cross C bar and height is nothing but, okay, from the top face, you drop the perpendicular to the ground face. All right. This is nothing but height. This is nothing but height. Well, okay. Now, what is meant by B bar cross C bar? B bar cross C bar is a vector perpendicular to the plane B bar and C bar. To the plane B bar and C bar. Now you see that B cross C is parallel to PQ, right? Okay. Or I have dropped from the point P to the B bar cross C bar perpendicular. Now it is easy to verify that OQ is equal to OR, right? OQ is nothing but this is OQ perpendicular. So similarly, PQ equal to OR, right? So here I am writing that H is equal to PQ. All right, this is equal to OR. This is nothing but projection of the vectors A bar. This is nothing but projection of, okay, projection of, 1 minute. I need little space. All right. Projection of, this is nothing but projection of A bar vector on B cross C, isn't it? So this is nothing but A bar dot B cross C whole by modulus of B cross C implies H into modulus of B cross C, just doing the cross multiplication. Numerator is nothing but box ABC. So this is nothing but volume of parallel pipe formed by A bar, B bar, C bar. This is the volume of parallel pipe formed by A bar, B bar, C bar. Here we assume that A bar, B bar form a RHS. What will happen if A bar, B bar, C bar form a LHS? If they form a LHS, then box ABC in fact negative. So therefore, negative of box ABC is the volume of parallel pipe that we do not consider much. Okay, of course we consider. So we don't know whether the given vectors are formed LHS or LHS. So we usually take that volume of parallel pipe of A bar, B bar, C bar equal to modulus of box of ABC. Modulus of box of ABC. And remember, it is very, very important that box ABC is same as box BCA, that's equal to box CAB. Like in anti-clockwise direction, this is A bar vector, this is B bar vector, this is C bar vector, okay? Rotating in anti-clockwise, wherever you start. If you start from A, then A bar, B bar, C bar box is same as B bar, C bar, A bar. Or you start from C bar, A bar, and B bar. Those are equal. If you interchange any two vectors in the box, then you will get negative. Like if you interchange any two rows in determinant, that resultant determinant has the value negative of given one, right? Negative of original value. And box of PA bar, QB bar, and RC bar equal to, you can bring out all those scalars out of the box PQR into box of ABC, box of ABC. Like for example, box of 2A bar, 3B bar, minus 4C bar. This is equal to 2 into 3 into minus 4 into box of ABC. That's it. So this is equal to minus 24 into box ABC. Well done. Okay. Now for right-handed system, you see, for right-handed system, that box ABC must be positive. If box ABC is positive, then they form a right-handed because volume of parallel pipe is positive. For left-handed system, that box ABC must be negative. Box ABC must be negative. Now, what is the volume of tetrahedron formed by A bar, B bar, C bar? Volume of parallel pipe, sorry, we have seen that volume of parallel pipe is equal to box of A bar, B bar, C bar. But here you see, what is the volume of tetrahedron? Tetrahedron means it is formed by four faces, triangular faces, four triangular faces. Okay, so this is equal to 1 by 3 into area of base into height. Area of base into height. That is equal to 1 by 6 into modulus of box of A bar, B bar, C bar. So here the triangle is ABC. Here the triangle is ABC. Proof is similar to that parallel pipe. Suppose 4 points are given. Suppose 4 points are given. A, B, C, D. Okay. You have to fix A. You have to fix A. You have to fix A. Then volume of tetrahedron is equal to 1 by 6 into box of AB bar, AC bar, AD bar. Like this, you can say here this is A and this is B and this is C and assume this is D. Okay. So if you join them, then you will get a tetrahedron like this. This is down triangle. Okay. This is one triangle and you join this tetrahedron. All right. So what is the volume of parallel pipe whose coterminal edges given by A bar, B bar, C bar is equal to 158, asking what is some value, isn't it? So volume of parallel pipe, here it is given that modulus of box of A bar, B bar, C bar is equal to, they have given that 158 cubic units, right? Cubic units. Okay. Now, it is just nothing but a determinant application, isn't it? So we just need to find out the determinant of the all three vectors, all three vectors. So here, what is the volume? That volume is equal to modulus of determinant of first vector 1, 1, n. Second vector 2, right? 4 minus n. And third vector 1, n, 3. This they have given is equal to 158. Questions are not at all difficult. They are just simple application of determinant. Once you know the concepts fully, then you can solve the questions. So here this is a 1 into that 4, 12, 4 into 3, 12, plus n square minus 6 plus n and plus n into 2n minus 4. This is modulus, of course. Okay. This is equal to 158. Okay. So this implies we can have that this is n square, this is 2n square, and this is n square. So totally we have 3n square. And this is minus 4n minus n, so minus 5n. And calculate what is the constant 12 minus 6, that is plus 6. Plus 6 equal to, you can write plus or minus 158. Right side you take only plus 158. If you take minus 158, you will get non-real roots, non-real roots. So therefore, this implies that I can write 3n square minus 24n plus 19n minus 152. All right. So this is nothing but you take that 3n common. This is n minus 8 minus plus 19 common and n minus 8. So implies n equal to either 8 or minus 19 by 3. Once again, have a look on the question whether they have given any n is greater than or equal to 0. N is greater than or equal to 0. Here you see that. N is greater than or equal to 0. So now therefore, we have that n is equal to 8. Of that, whatever you want to find out, you can find out a bar dot c bar, b bar dot c bar, like that, right? Anyway, n is equal to 7 and 9 are not at all true. So you need to find out a bar dot c bar and b bar dot c bar. Well, this is let the volume of parallel pipe whose coterminous edges are given. If theta is the angle between W bar and U bar and W bar, then what is the cos theta? This is the similar procedure. Okay, you please try to solve it. You can find the value of lambda. You can find the value of lambda by applying that box of U bar, V bar, W bar modulus, or this is equal to plus or minus 1. You find what is the value of lambda, right? And then cos theta is equal to, okay, angle between U bar and U bar dot W bar whole by modulus of U bar into modulus of W bar. Well, okay, here is one more question. This is regarding minimum of the value. Okay. So what is the volume of parallel piped? Three vectors given, so that volume of parallel piped is minimum, right? So volume is equal to, that is box. Box is nothing but determinant. So 1 lambda and 1, and second one is 0 1 lambda, and the third one is lambda 0 1. Right. Okay. So this is equal to 1 into 1, right? Minus lambda into minus lambda square, isn't it? And minus lambda square. So this is equal to lambda cube minus lambda square, okay, plus 1. Once again, let me check that. First vector is 1 lambda 1, second vector is 0 1 lambda, third vector is lambda 0 1, and 1 into 1 minus lambda into 0, lambda into, this is 0 minus lambda square, and plus 1 into, this is minus lambda. Oh, nice. I did a mistake here. This is only just this lambda. All right. Okay. So assume this is f of lambda. For minimum and maximum, that we find that f dash of lambda is equal to, we write that 3 lambda square minus 1. Apply the sine rule of in which interval it is increasing, in which interval it is decreasing. It is minus 1 by root 3 and 1 by root 3, right? Left side of minus 1 by root 3 and right side of 1 by root 3 increasing. In this, here it is decreasing. Well, here you will get maximum and here you will get minimum. What do you want? Minimum. So lambda is equal to 1 by root 3. At lambda equal to 1 by root 3, we will get minimum value. All right. Okay. Remaining questions you try. And one more important concept I am going to explain this. That is box of linear combination of vectors. Box of linear combination of vectors. So what is this box of linear combination of vectors? First vector is L1 A bar plus M1 B bar plus N1 C bar. Right. Well, so assume that first vector is alpha. This is alpha bar. And the second vector is beta bar. And the third vector is gamma bar. Right. Okay. So this is nothing but determinant of all scalar components L1, M1, N1. These are the scalar components of first vector, right? And next B bar vector. See the B bar vector. What are the scalar components? L2, M2, N2. L2, M2, N2. Next, L3, M3, N3. L3, M3, N3. That's into box ABC. That into box ABC. The proof is quite simple. You have to apply a brute force method, just applying that cross product of two vectors and taking dot with the third vector and taking dot with the third vector. Right. Well, so this is nothing but This is nothing but box of alpha bar, beta bar, gamma bar. We have to apply that alpha bar cross beta bar individually term by term you have to do and taking with the dot gamma bar. You need time. Do it term by term. Then you will get such a beautiful result. I'll give you one example based on that. Okay. Or here is an example, not necessary. I have picked one previous JEE mains question. You see, let A bar, B bar, C bar represent three coterminous edges of a parallel pipe of volume B. Isn't it? First sentence is over. Second sentence, then the volume of parallel piped whose coterminous edges represented by A bar vector, B bar plus C bar vector, A bar plus 2B plus 3C vector. They are asking what is that volume? All right. It is very simple. So they have given that volume of parallel pipe. So V is equal to box of A bar, B bar, C bar. This is the V. Now we want to find out that new parallel pipe volume formed by A bar, B plus C and A bar plus 2B bar plus this. So what is the new volume that V1 is equal to? Again, box of, okay, first vector A bar, second vector B bar plus C bar, and third vector A bar plus 2B bar plus 3C bar. Once you understand that concept, it is so simple. So this is nothing but a determinant of, okay. See here A bar component is 1. There is no B bar component. There is no C bar component in the first vector. Isn't it? Here there is no B bar component. There is no C bar component. And then. Let us have a look on the second vector 0, 1, 1. Have a third that is 1, 2, 3. Now into box ABC. You can solve it just in 1 minute. This is equal to 3 minus 2, that is 1 into V. Question is finished. Like this, you try to practice the remaining. And here one more important property, that box of L, M, N into box of A bar, B bar, C bar, right? Box of LMN is nothing but determinant. Box of ABC is nothing but determinant of the vectors. Here I have not specified that what is L. L is equal to L1I, M1J plus N1K. etc. like this. And here A bar is equal to A1I plus B1J plus C1, etc. Right? Or else you can say this is A bar vector and this is B bar vector and this is C bar vector. Now we do the multiplication of determinants either row by row, column by column, row by column, column by row. There is no restriction like in multiplication of two matrices. You can do the multiplication in any manner. In any manner. So if you do the determinant multiplication row by row, okay, row by row. L1A plus L2A2 plus L3A3. This is nothing but A bar dot L bar. A bar dot L bar. Next, L1, L2 multiply with B1, B2, B3. You will get L bar dot B bar. Now multiply L1, L2, L3, L1, L2, L3, this L1, L2, L3 with the third row. You will get this sigma L1, C1. That is nothing but L bar dot C bar. So we got it. Once you got the first row, okay, once you got the first row, secondary you write. See here we have taken dot A, B, C with L bar vector. Now you have to take the dot A, B, C with the M bar vector. In third row you have to take dot with the N bar vector. Right. So what will happen if you substitute LMN is equal to box ABC? Substitute that box LMN is equal to box LMN is equal to box ABC. Well, then you will get that box of ABC whole square. Box of ABC whole square. This is box of ABC. Okay. And box of LMN. All right. So substitute LMN. Here substitute LMN. You will get. Here substitute LMN is equal to A bar, B bar, C bar. Then you will get that box ABC whole square is equal to box ABC whole square equal to determinant of, first you take dot A to all ABC. Dot A to all ABC. Right here you see dot A to all ABC. Next take dot B to all ABC. And you take dot C to all ABC. This is a very, 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 very important box ABC whole square formula. So box ABC whole square is equal to A bar dot A bar, A bar dot B bar, A bar dot C bar, first row. Second row, B bar dot A bar, B bar dot B bar, B bar dot C bar. Third one, C bar dot A bar, C bar dot B bar, C bar dot C bar. This is a very, very important and ultimate result in vector or in scalar triple product. Suppose angle between A bar, B bar, C bar is theta, right? Between any two vectors, they are equally inclined at the same angle. They are equally inclined at the same angle. Then box ABC whole square is equal to, what is A bar dot A bar? Mod A square. What is A bar dot B bar? Mod A mod B cos theta. What is A bar dot C bar? Mod A mod C cos theta. So I have taken those all lengths and this final determinant is left. Okay, here this is mod A bar is equal to, I have taken A, mod B bar is equal to, I have taken B, and mod C bar is equal to, I have taken C. So once again, you just apply the dot product A bar dot B bar is nothing but mod A mod B cos theta. And here A bar dot C bar mod A mod C cos theta. That's it. On expanding this determinant, you will get a beautiful result. This expansion is very, very important. A square, B square, C square into 1 minus cos theta whole square into 2 cos theta plus 1. All right. So, if angle between A bar, B bar, B bar, C bar, C bar, A bar is equal to theta, where theta belongs to 0 to 2 pi by 3, right? Theta belongs to 0 to 2 pi by 3 because This must be always positive. Must be always positive. So 2 cos theta plus 1 must be positive. It is positive when theta belongs to 0 to 2 pi by 3. If theta equal to 2 pi by 3, then this value becomes 0. 2 cos theta plus 1. Then box is equal to 0. Then A bar, B bar, C bar are coplanar vectors. So if angle between any pair of vectors of A bar, B bar, C bar is 120 degrees, then definitely A bar, B bar, C bar are coplanar vectors. I'll give one example based on this fact. Here is an example of course, this is previous IIT question. Suppose that A bar, B bar, C bar are unit vectors and any pair of vectors angle between any pair of vectors, sorry, and angle between any pair of vectors is 60 degrees. Then the volume of parallelepiped formed by A bar, B bar, C bar. Then the volume of tetrahedron formed by A bar, B bar, C bar. Well, so what is the volume of parallelepiped formed by A bar, B bar, C bar? It is a box ABC. Yeah. So we need to find out that box ABC. This is the box ABC. And this is 1 by 6 box ABC. All right. So in either cases, you need to find out what is box ABC value. Right. So we have that box ABC whole square formula. Box ABC whole square is equal to determinant of, remember, you take dot with all three vectors, A dot A dot B, A dot C. Take a dot A with A. Now take dot with B, B dot A, B dot B, and B dot C. Well, and this is finally C dot A, C dot B, and C dot C. Isn't it? This is all. Now, this is equal to determinant of, as A bar, B bar are unit vectors, this is 1. And A bar dot B bar is nothing but mod A mod B cos 60. Mod A mod B cos 60, that is equal to 1 by 2. And mod A mod B cos 60. Like this, you will get 1 by 2, 1 by 2, 1. Once again, I am explaining that A bar dot B bar is nothing but mod A mod B cos theta. A, B, C are unit vectors. They are unit vectors. This is equal to 1 into, all right. So 1 minus 1 by 4, that is equal to 3 by 4, minus half into 1 by 2 minus 1 by 4, that is 1 by 2 minus 1 by 4, nothing but 1 by 4, plus 1 by 2 into 1 by 4 minus 1 by 2. Okay, 1 by 4 minus 1 by 2. 1 by 8. All right. 1 by 4 minus 1 by 2. Minus 1 by 8. So this is equal to, you can write 9 by 16 minus 2 by 16 plus 1 by 16. That's equal to 1 by 2. Remember, this is box ABC whole square. Sorry, this is box ABC whole square. All right. So therefore, box ABC value equal to, box ABC value is equal to 1 by root. Thank you. Use my channel and enrich your knowledge. Keep mind peacefully and aim for JEE Main and JEE Advanced.